Hi, how are you? Hello. How can I help? This is a consultation time. Do you have a mic? Do you have a mic?
Yeah, I have mic.
Yeah. Okay, so what's your problem you want to ask? Hello?
I'm sorry.
Yeah, this is a consultation. Do you have a question?
And this is supposed to be the tutorial 8 and tutorial 8 question.
No, tutorial 8 is at 10 o'clock. No, man.
10 o'clock? Oh, sorry, I missed it.
You missed it. Yeah, come on. It's 10 o'clock. 11 to 12, that's a consultation time.
Okay. Yeah, I missed it. Sorry.
No, good. No problem. It happens. Well, you have been here like for so many weeks. You should know, right?
Yeah.
Oh, hold on a second.
I think this is the tutorial time, I think.
Yeah, you are right. I was wrong. Yeah, it is supposed to be tutorial time now. Okay.
Yeah.
So yeah, let's get started anyway. Okay. Let's get started with the tutorial question. Let me just grab my iPad so I can share my screen with you. I'm gonna connect it. So again, it's just you and me. My bad, sorry. I thought this is consultation time. Have you do your problem set too?
Yeah, I've done it.
Done it? Easy? Super easy, right?
Yeah.
Okay, excellent. Good. So let's take a look at our tutorial number 8. Okay. So I'm gonna share my screen with you now. Share screen. Okay. Can you see it?
Yeah.
Okay, let's get started. So this is about expected utility, right? We suppose that we have stage 1 with occurring probability pi, and stage number 2 will have a occurring probability 1 minus pi. So they are mutually exclusive. So either this will be stage 1 or stage 2. Okay. So therefore, the expected utility is a combination of those two outcomes. That would be utility C1, C2 equals to pi times UC1 plus 1 minus pi times UC2. Where pi UC1 and UC2 is simply the utility for state 1 and 2. Then therefore, we'll have a Bernoulli utility function, or sometimes we call this von Neumann. And this we end up Vn utility is no longer ordinal. Okay. So therefore, we say the magnitude matters. Okay. So as for the independence of mu across states, we say marginal utility 1 equals to pi times the u prime c1, and marginal utility 2 for state 2 will be 1 minus pi times u prime c2. Well, obviously this depends on what? Depends on the utility function itself. Okay. And therefore, with marginal utility, we can calculate what? We can calculate the marginal rate of substitution. Okay. So therefore, MRS C1, C2 equals to minus MU1 over MU2. Since we have already calculated MU1, MU2, we know this will become minus pi times U prime C1 over 1 minus pi times U prime C2. Okay. So this is about the marginal utility MRS. Next thing we need to talk about is actually, if we understand the utility function, then we will understand there are three types of persons who have different perspectives on their preferences on risk. The number one, we have risk averse person. Their utility of expected outcome will be greater than the expectation of the utility. Okay. So on the left-hand side, UEX, that's the utility of expected value. And on the right-hand side, EUX, that's expected utility of X. Okay. So if the utility of the expected value is greater than expected utility of X, we know this person is risk averse. Averse means the opposite of loving. Okay. Means I don't want to take risk at all. And in this case, the utility function will be strictly concave, as we will see in a second. And next we have the risk neutral person. And for this person, the utility of expected value, UEX, will equals to expected utility of X. Therefore, the utility function will be simply a linear function, means a straight line. And lastly, we have a risk loving person. And for this person, the utility of expected value will be smaller than the expected utility of X. Okay, that means UEX smaller than EUX. Okay, therefore the utility function will be strictly convex, as we will say soon. So since we talk about those three different kinds of utility functions, let's take a look graphically. Number one, in the very left-hand side, we'll have a risk averse. Okay, as you can see, the expected utility of expected value function, the blue line, is strictly concave. Okay, and for example, we can have utility function as 10 times square root of X, because we know square root function is a concave function. And as for the purple line, that's expected utility of the outcome itself. And as you can see, for a given output X, the utility of expected value, which is on the blue line, is higher than expected utility, which is on the purple line. Therefore, we know this is strictly concave function for risk averse person. Next, we have the risk neutral person in the center of the graph. As you can see here, the utility of the expected value will equals to the expected utility of X at any given point of X, where X is simply the output. And for example, this function can be UX equals to X, because all we require is this to be a linear function. Okay, and in this case, the utility of expected value will equals to expected utility of X. Simply. Next, we have risk loving. So for example, we can have this function as UX equals to X squared. Okay, so as you can see here, the blue line, which is the expected utility of X, of expected utility of expected value of L, is a convex function. Okay, outward sloping convex function. And as for our expected utility, that's a straight line again. So as you can see, at a given level of X, the expected utility of X will be bigger than the utility of expected value of X. And in this case, we call this person as risk loving. Okay, so that's just graphically how do we see a person is risk averse, neutral, loving. All we need to do is determine the slope of the function. Okay, if we know this function is a concave function, then we know this is risk averse person. If we know this is a convex function, then we know this person is risk loving person. And if this is a linear function, then we know this person is risk neutral. Okay, that's pretty simple. Any questions? How you and Jing Tao so far? As a quick review on lecture stuff. Questions? All good? Excellent. Okay, let's move on to our question number one. So in this question number one, we have a Pandora virus known as PAVID. It's out of the box. Ephesus has an initial values of $10,000 and von Neumann Morgenstern utility function, or we know this is a Bernoulli function, right? Over values given by UW equals to ln W. Living a repetitively vibrant social life, he has a probability of 30% of contracting the virus. Conditional on contracting the virus, there's a 30% chance that it becomes severe, which has the effect of reducing his bills by $6,000, and a 70% of chance that he suffers minor illness, which has the effect of reducing his bills by $100. So graphically, he has a okay. He has, first of all, he has a 5% chance to get the virus, right? And therefore there will be 95% of the chance not getting the virus. And conditional on he got the virus, there's 10% chance this will be severe, and 30% chance this is severe, and 70% chance this is not severe. So we know our VELS W equals to 10,000, and the utility function is ln W. Okay, and we know how do we draw logarithm function. Do you guys remember how do we draw logarithm function? Logarithm function is simply something looking like this. And since we know the shape of a logarithm function, we know this is what? This is concave or convex. Guys, what do you think? Is this concave or convex function? Very good. And we know for a concave function, this person must be risk averse, right? Risk averse, okay? So next, we know the probability of getting the virus is, the probability of getting severe conditions will be 30%. So pi equals 0.3, then VELS will be minus 6,000. And therefore there's other 70% chance, so 1 minus pi equals 0.7, the VELS will minus 100. So we need to calculate his expected utility. So if not contracting the virus, his utility will be UVEL equals to ln 10,000, okay? Log of 10,000, which is approximately 9.2103. Okay, so this is the case when he's not getting the virus at all. And what about when he get the virus? When he actually get the virus, we denote this by you sick. Okay, utility when you're sick will be, sorry, excuse me, 30% of the chance you will lost $6,000. Okay, and there's another 70% chance you will lost 100%. Oh, sorry, $100. So therefore, our utility function for a person to get sick will be U sick equals to 30%, 0.3 times log of 10,000 minus 6,000 plus 70% chance, 0.7 times log of 10,000 minus 100. By calculating this, we know this utility sick will be 8.9284. Okay, so his overall expected utility will simply be a combination of UVEL and U sick. And again, we know the chance of getting the virus, 30%, right? So the probability of being well will be 30%. Sorry, the probability of getting the virus, which will get you sick, will be 30%. So 0.3 times you sick plus 70% chance you will stay well. So in the end, 0.3 times 9.2103 and 0.7 times 8.9284, you would get 9.1258 as your answer. Okay, that's pretty easy. Question A. Any questions, guys? Everything all good? For question 1. Excellent. Question B. Suppose the government can enforce a law which will reduce the probability of contracting virus to 10%. However, lockdown will also reduce his bills by X dollars. Okay, so now we need to assume that the bills will be lost by X amount. Okay, we don't know that yet. So write down the equation that defines the maximum amount of X that he's willing to suffer for the lockdown. So with a lockdown, his utility without contracting the virus will be what? Will be log of 10,000 minus X. Okay, we know what is X. X is the amount of money he will lost because of lockdown. Okay, and this will be utility when he's well. With a lockdown, his utility with catching the virus will be UVEL equals to 0.3 times log 4,000 minus x plus 70% chance times log 9,900 minus x. So my question is, okay, we want to understand this 30% chance getting severe condition, 70% chance getting minor conditions, and we know the x is from lockdown. The question is, what is 4,000? Where's 4,000 coming from? Guys, any idea where's 4,000 coming from? Any ideas where's 4,000 coming from? Think. What have we done? Exactly, very good. How are you? This is exactly 10,000 minus 6,000, right? Because when he gets severe condition, it will lose $6,000 with or without lockdown, okay? And similarly, 9,900 is from 10,000 minus $100 of cost for minor condition, okay? And therefore, we'll get USIC function, okay? U will and USIC. Then in the end, we can write down the expected utility when there's a lockdown. Remember, here's not 30% and 70% anymore. Because with a lockdown, the probability of contracting the virus has reduced to 10% instead of 30%. So we use U equals to 0.1 times USIC plus 0.9 times U will. So therefore, it's simply 0.1 times 0.3 times log 4,000 minus x plus 0.7 times log 9,900 minus x times 90% chance 0.9 times 10,000 minus x. Okay, log 10,000 minus x. This is the case when he's not getting the virus, which is U will. We have calculated U will over here, so simply we just plug in that term inside here. And similarly, we're plugging USIC into this function over here, okay? So this will be the case under the lockdown, right? But we're not really interested in this. We are interested in what amount of X he will accept. So for him to be willing to accept the lockdown, U must be at least greater than his expected utility in question A, right? Because otherwise he would not accept the lockdown. He would do a protest and asking his friends to walk out of the home, not doing the lockdown. So therefore, the utility in question A, which is the utility without a lockdown, needs to be greater than his overall utility, expected utility, under the lockdown, okay? So that is saying that what we have calculated above, U equals to 0.1 times 0.3 times log 4,000 minus x plus 0.7 times log 9,900 minus x plus the 0.9x times log 10,000 minus x needs to equals to 9.125a. That it will be that will be the giving us the maximum amount of x he will accept for the lockdown, okay? And you remember where's 9.125a coming from? 9.125a is simply the solution from question A, whereas there's no lockdown at all, okay? So does it make sense, guys? For question 2, question B? In a sense, all we did here is just plug in the x and using the new probabilities and comparing this with the original utility in question A. And therefore, we can calculate the amount of x, okay? Are we all good for this step? Hello, hello. Yes, good, thank you, how are you? So therefore, we can solve it, right? So the question is, it is not possible to solve x algebraically here. If you do want to solve for it, you need to solve it numerically. So that means using computer to approximate the solution. So it is not that hard though. You can do it with the Excel, okay, by using the Newton's methods. By this way, the numerical answer will be x approximately 523 to the nearest dollar. okay, in case you'd like to know. So however, this is not required. You don't have to calculate the amount of X. All you need to do is just write down this condition over here, okay, which is the maximum of X needs to be satisfied. All right, so question C. Hippocrates Pharmaceutics has developed a vaccine against COVID. For simplicity, suppose vaccination brings no externality, so therefore the vaccine reduced the vaccinated person's probability of contracting the virus to 5%. Okay, that's great. So now if you take the vaccine, you will be only 5% chance getting the virus and 10%, 95% chance not getting the virus. Moreover, upon contracting the virus, a vaccinated person develops severe illness with a probability of 10%. So therefore, the probability of getting severe illness has reduced to 10% as well. And minor illness with 90% chance. Calculate his expected utility after receiving the vaccination, assuming the vaccine is free and costs no reduction in the utility. Okay, so this is pretty easy. We know his utility if he does not contract the virus is the same as before, right? Which is what we have calculated in in question A, which is 9.2103. That's his utility of not contracting the virus. If he is vaccinated and got the virus, we can get his expected utility as U6 equals to 0.1 times log of 4,000 plus 90% times log of 9,900. So this will be approximately how much? 9.1097. Remember, we don't need X over here because this is not the case for lockdown. We only care about what? The vaccination effect. So we still use 10%, 90% here. And this is not because of the lockdown. This is because the probability of getting severe illness has reduced to 10% because of vaccine. So therefore, if we have U6 and U-well, we can calculate the overall expected utility of after the vaccine, which is 5% of the chance you're getting really sick and 95% of the chance you're getting well. And by plugging those two numbers into it, we got how much? 9.2053, okay? That will be the expected utility after vaccine, okay? So by comparing vaccine and lockdown, which one is better? We don't know, okay? You need to plug X equals to 523 into the equation, then you can compare. But obviously, 9.2053 is better than our answer in question A, right? Which is 9.1258, okay? It's much better than that. So I would say people have more incentives to take the vaccination, okay? So that's our question C. Anything you want to ask Jintao and how you? Everything all good? Nice, thank you guys. So question D, unfortunately, he read misinformation on social media and suffered a difficulty of 0.1 units, sorry, utils, that's utility unit, if he get the vaccine, okay? Will he take the vaccine voluntarily? So this is saying that he will lose 0.1 units of utility because he read some information saying vaccination is bad and he refuses to take vaccine, okay? So therefore, the gain in his utility from vaccine is difference between answer part C and part A, okay, as we said previously. If he doesn't take vaccine, his utility will equals to 9.125A. If he take vaccine, his utility will be right here, 9.2053, right? So therefore, all we need to compare is the difference between 9.2053 and 9.1258. And compare that against the disutility of 0.1. if the difference means the marginal gains of taking the vaccine is greater than the disutility of taking a vaccine, then he will take the vaccine. However, in our case, the difference is only 0.0795, so very small marginal difference for his utility. Therefore, because 0.0795 is smaller than 0.1, he will not get the vaccine voluntarily. Why? Because, again, this is extra utility from taking vaccine, right? Which equals 0.0795. On the right-hand side, that's this utility from taking vaccine. So obviously the disutility is greater than the extra utility gained from the vaccine, so he will not voluntarily take the vaccine. All right, that's question 1D. So interesting thing is, remember we said his utility function is a concave function, so therefore he needs to be a risk-averse person, right? And finally, he's not willing to take the vaccine, and which is not exactly what we expect from risk-averse person, because risk-averse person would love to eliminate all the uncertainties and not willing to take risk at all. And here, as we can see, the reason why we get the result he will not take the vaccine is somehow because he has read some misinformation on social media. Okay, so that's question 1. How you and Jintao? Anything you want to ask for the question? Is everything all good? No. Thank you. How you? How about you, Jintao? Are you all good? Okay, cool. Question 2. Suppose there is an urn containing 300 balls. Of those 100 balls are red. So in 300 balls, there are 100 balls are red. Okay, and there's a box of 200 other balls. In this 200 other balls, there is a 200 times P will be black, and 200 times 1 minus P will be white. What is a P here? P is simply the probability of the ball being black out of those 200 balls, okay? So therefore, 1 minus P will be the probability of the balls being white out of those 200 balls, okay? So we have 2 gambles. Gamble 1A, you receive $10 if you draw a red ball, 0 otherwise. Gamble 1B, you receive $10 if you draw a black ball, and 0 otherwise. And there's a second pair of gambles, that is gamble 2A, you receive $10 if you draw a red or white ball, so both red and white ball, otherwise you get 10. Gamble 2B, you receive $10 if you draw a black or white ball, 0 otherwise. Okay, so question A, normalize the utility from getting 0 to 0 and let U10 to be the utility from getting $10, obviously utility of $10. Let P be the proportion of black balls among the 200 balls, and suppose an expected utility maximizes strictly prefers gamble 1A among the first pair of gambles. What must her believe about P be? Okay, so normally we don't know if this person is a utility maximizer strictly prefers gamble 1A or not. Okay, normally we will know the P, but however, we're doing this the backwards now. Okay, we're trying to work out the P by knowing this person will strictly prefer gamble 1A. Okay, so therefore, how do we do this? All we need to do is to compare the expected utility from gamble 1A and gamble 1B. Okay, and by this comparison, we'll know the value for P. Okay, so first of all, the expected utility from gamble 1A, that will be the proportion for red balls, because how many red balls we have? 100. How many total balls we have in total? 300. So 100 over 3, 0.63 times utility of $10, because the gamble 1A said if you get a red ball, you will get $10. Okay, plus the probability of not getting a red ball. Okay, means otherwise 200 over 300 times 0. So therefore, your utility from gamble 1A will be 1 over 3 times U10. Okay, Next, we can calculate the expected utility from gamble 1B, okay? Gamble 1B is that if you get black ball, you get $10. If you get all the other balls, you will get 0. So therefore, we have 200p over 300. Remember, what is 200p? 200p is how many black balls in the box, in the urn, okay? So therefore, the 200p over 300 is the probability of getting black ball in total. 200p over 300 times U10 plus 1 minus 200p over 300 times 0, you will get 2p over 3 equals to U10. So if this individual strictly prefers 1A to 1B, it must be because utility 1A is bigger than utility 1B, isn't it? Okay, so therefore we know 1 over 3 U10 will be bigger than 2p over 3 times U10. We can get rid of U10 here, we can get rid of 3, so we know P is smaller than 1 over 2. Okay, does it make sense, guys? P smaller than 1 over 2. That's how we solve question 2A. This is pretty simple. All you need to do is just list those two utility functions and compare them and get P. Okay, questions? All good? Tao, how are you? I'm gonna keep pointing at you guys. All good? Okay, excellent. How are you? Yeah, thank you guys. Let's look at question B. Now suppose an expected utility maximizer strictly prefers gamble 2B. Okay, so we need to do exactly the same stuff for the second gamble 2. Again, all we need to do is calculate the expected utility for gamble 2A and gamble 2B. And because we know strictly prefers to gamble 2B, so we know 2B will be bigger than 2A, then we can solve for P, okay? So utility 2A will equals to 100 over 300. That's the probability of getting a red ball, plus the probability of getting the white ball. Because if you remember, the gamble 2A says you receive $10 if you got a red or white ball. Oh, okay, very important words here. It's a or, so this is like you can either get red or white, doesn't matter, you'll get $10, right? So therefore, in this question, the probability will be the probability of red plus probability of white times the utility of $10 plus the probability of black. And we know if you get a black ball, you will get nothing, right? You get $0. So simplify this equation. This will become 1 over 3 plus 2 times 1 over P over 3 times U10. Okay, that's pretty simple. We got utility for gamble 2A. How about the expected utility from gamble 2B? So for gamble 2B, you will get $10 and utility will be U10 if you get either black or white balls. Remember how many black and white balls in total we have? We have 200 of them, right? 200 black or white balls out of 300 balls in total. So we know this probability will be 200 over 300, okay? 2 over 3 times U10 plus 1 over 3 times 0. So we know 2 over 3 times U10. If this individual strictly prefer 2A to 2B, sorry, the other way around, strictly prefer 2B to 2A, okay? This will be U2B greater than U2A. Or because we have calculated U2B, U2A, we know this is 2 over 3 U10 greater than 1 plus 2 times 1 over P, 1 minus P over 3 times U10. That is, if we get rid of U10 and get rid of 3, this will be 1 over 3 greater than 2 or 3 times 1 minus P. So we know this will be 1 minus P smaller than 1 over 2, or P greater than 1 over 2. Okay, that's question B. Again, this is pretty simple. The only more difficult thing is how we work out the probability of red and white. Okay, so you just add those two probabilities up, then you can get the joint probability of getting either red or white balls. Okay, so that's for getting either black or white balls. This will be 200p plus 200 times 1 minus p, okay, which will give you 200. That's pretty easy. Let's take a look at question C. Given your answer to A and B, can you expect it Can expected utility maximizer strictly prefers 1A to 1B, while strictly prefers 2B to 2A. What do you guys think? Yes or no? Yes or no? What do you guys think? How you know? Juntao, what about you? Yes or no? Come on, Juntao, are you still there? Okay, we probably lost Juntao. Okay, Juntao, no, excellent, good job. Why is that? Take a look at our question A. The condition for we prefer gamble 1A over gamble 1B will be P smaller than 1/2. And the condition for gamble 2B to be better than gamble 2A will be P greater than 1/2. Can we simultaneously have P smaller than 1/2 and greater than 1/2 in the same time? No, those two conditions cannot be satisfied simultaneously. Simultaneously means together in the same time, right? So it is impossible for an expected utility maximizer to strictly prefer 1A to 1B and 2B to 2A in the same time. Okay, they cannot be preferred in the same time. Otherwise, this is a contradiction on the purposes, and this person will not be a utility maximizer. He's making his decision based on some other factors instead of utilities. Okay. Question D. Economy experts typically find a significant proportion of subjects choosing 1A and 2B simultaneously. Are you one of them? What do you think you might be the reason for that? Okay. Again, this is an open question, guys, so you can come up with your own answer. I'm just providing one possibility. The truth is, nobody knows for sure, right? And so many economists conjecture that individual prefers gambling with a known probability distribution. That is, that we know gamble 1A and 2B. Okay, notice that their values do not depend on P, right? As you can see, gamble 1A, that is 1/3 times U10, okay? And gamble 2B, that's 2/3 times U10. This is something for certain, okay? It doesn't has a P in it. No probability of black and white, okay? No probability of black and white. Probably is because people prefer certainties over uncertainties, right? So let's get back here. So to gamble with an unknown probability distribution, a concept known as ambiguity aversion. Okay, so this is one possible solution. By now, ambiguity aversion has generally been accepted as possible way to modeling individual behavior under uncertainty, in the sense that even the probability distribution over states of the world is unknown and has found application in economics and finance. So basically, this is very behavioral economic stuff, something called ambiguity aversion. In simple words, this simply means people really don't like uncertainties, okay? They prefer certainties over uncertainties. So if you give them a choice that, okay, you can either choose to get 1/3 times U10 or you get 2p/3 times U10. So that's 2p/3 times U10, that will be a probability, and they don't want that, so they will prefer 1A. And this is a possible solution, which is ambiguity aversion, okay? So again, come up with your own answer. This really doesn't matter. I don't think you'll be answering this kind of question in your problem set as well, okay? So that will be the end of this week's tutorial, okay? I'm really happy that 2 of you guys made it. I understand that of you guys having the problem set to doing today. So I know how you just told me he has done it. Juntao, have you finished it? Have you finished your problem set too? Yes, excellent. You guys are doing great. So, yep. Do you have questions? If no questions, we will call it today. Okay, then I'll let you guys go. Then you can probably do your other assignments or preparing for other stuff. Okay, and have a great weekend, guys. Don't stress yourself out too hard. Have a great weekend. Always remember to chill. Okay. Thank you, Hao Yu. Okay. I'll see you next week. Bye-bye.